Hi, welcome back to Missing Chemistry. This is going to be a Hess law equation problem. And this is going to be a little bit different than the first one. The first one that we did, lesson 1A, was a little bit more difficult. So let's go back and look at something a little bit easier. Okay, it says find the change that enthalpy changes to predict the enthalpy change in the reaction of ethene with chlorine gas. All right, so what we have is we have this equation right here. And what we want to do is we want to make these three equations look like that equation. Okay, so we're allowed to divide things, we're allowed to flip things, we're allowed to do a lot of things. And this is what's really cool about Hess equations, was that this guy, I think it was at Yale University, and he figured this out back in the 19th century, which is the 1800s, which was pretty good considering the technology at the time. So I'm going to go ahead and clear that out real quickly. I just did those things. And all right, so now we got CH2 for gas. So we see that here, and we see that one here. Okay, and let's see here. We've got the Cl2 on the right side there, so that looks okay. And we've got the HCl on this side, which looks, let's see here. That'll be okay because we're going to cancel one of those. But what we want to get rid of course, is the C2H5Cl. All right, because it's not even in the equation, right? So we're going to want to get rid of that. Let's see. Let's go ahead and do that real fast here. So we're going to want to flip an equation, I believe. Yes, we are. We're going to want to flip the third equation. We're going to call this equation, this is going to be, hang on, let's see here. Let me clear something here real quickly. Okay, this is going to be equation 1. This is equation 2. This is equation 3. I'm going to want to flip equation 3. What that means is I'm going to flip everything around. So let me show you how I'm going to do that. So I'm just going to simply take this. All right. And I'm going to flip it. And I'm going to make it, let's see here, C2, H5, Cl, and that's going to be a liquid state, yields C2, H3, Cl gas state, plus H2, which is also the gas state. When I flip it, I also have to flip the sign, so that was from negative to a positive. Okay. Now I can go through and cancel things. Let's go ahead and change the color so we can see this cancellation a little bit better. Let's try that one right there. All right, so now we're going to cancel out one of our H2s. We don't want it on this side of the equation, and we don't want it on this side of the equation, so the H2 is gone. Okay, we're going to want to cancel out the C2H5Cl because it's not in the equation at all. So we're going to cancel that one out and cancel that one out. And I think that's about it. So now what we need to do is add up all three equations to get see if we made the copy that we were supposed to make. So go back to the original color there. So let's add this all up and see what we've got left. Okay, so we do have C2H4. So we go to C2H4 gas, and it's on the right side of the equation. We do have our Cl2 here, so that's going to work there. That's going to be a gas. Oh, look at this. We got to get rid of that HCl right here. This HCl has got to go. Luckily, we have two of them right here, right? So let me change colors one more time. And this is the beautiful thing about Hess. You keep on working until you get it done. So that HCl is going to go, and that's going to get rid of that 2, make that a 1. All right, now let's go back to our other color. And let's see here. So now that's going to give us C2H3Cl gas plus HCl gas. Wow. Hey, that worked out well. So now what we're going to do is we're going to add these 3 numbers up together, and they're going to give me a delta H value of negative 110 kilojoules. And that's it. Isn't this really snarly? You know, once you get the hang of Hess, it's not really that bad. It's just all that flipping and dividing and trying to figure out who goes where and what goes where. It's kind of like solving a puzzle. Well, listen, you guys, be snarly. We'll see you back here at Moosing Chemistry.